Hi, this is Richard C. I'm a math tutor here at Wyzant. I chose to answer this question from a student. It caught my eye because it's so important. It's really important to understand how money works. And I think our schools don't pay nearly enough time and attention on financial literacy. So I'm going to answer this question and help you out here with this. This is a formula that I use personally all the time, and it's A equals P times 1 plus over N. I'll explain it in a second, NT. Okay, so A is the ending amount. P is the principal or the starting amount. R is the interest rate, the annual interest rate. N is the compounding frequency. How often does the money compound? Now, if you don't know what that means, what it means is interest is paid out on the account every month or every quarter or every year. Those are the compounding frequencies. Once interest is paid and you leave the money in the investment, then you'll earn interest on the interest the next time it's compounded. So the idea of compound interest is a very important concept, and it has fascinated financial people for many, many years, and also some very famous scientists and so on. Okay, so let's go back and just use this formula. I'm not going to do the calculations for you. You're going to have to do them. I'm just going to set them up for you. So compounded annually, 20,000. So we want 23,000 is the starting amount. 1 plus R. Now, how many times per year is this compounded? Well, annually means it's compounded once. So N is 1 here. And then after 6 years. So that's all you need. And sorry, R, I should fill that in obviously. R is 0.049. Okay, so that would be the annual. I guess I'll do the first one for you, then you can. So 1.049 raised to the 6 times 23,000. So 6 years later, this 23,000 investment would have grown to 30,646. And so it's just calculator work. So here again, we're starting with 23,000. But here we're compounding monthly. So it's going to be 1 plus 0.049 divided by 12. So monthly is 12 compound periods per year times 12 times 6. So the work there is a little more complicated, but no big deal. And then C, A is going to be 23,000 times 1 plus 0.049 divided by 365 every day. So it's compounding daily. You don't see this very often, but sometimes you do. And so it's going to be 365 times 6. So because we're putting in the same amount in these three different options, the one that compounds most frequently is is C. This is going to produce the largest balance after 6 years. And these are all realistic things. Like you can buy a bond, for example, that pays interest annually, or you can buy a bond or some other investment that pays monthly, or you can find an account in a money market account that pays interest daily. Okay, so there are all these different accounts out there, and you need to know this formula if you want to figure out, which one is beneficial for you, most beneficial, and also you want to also play around with the formula because maybe you have a certain amount that you want 6 years from now. Maybe you want to put a down payment on a house, and you want to have a certain amount of money available for that. And so maybe 23,000 is more than you're going to need, or maybe it's not. Maybe you need to invest more than 23,000 in order to have the amount you want for your down payment. If you want a down payment of 30,000, then this works just fine. This investment works fine. Okay, and then the continuous compounding, this is a different formula, so I'm going to put that in now. So this is just A equals P e to the RT. We call this formula PERT. This is the same. R and T and A and P are all the same thing. We don't have an end here because we're compounding this continuously. So in other words, every second of every day. Now, this doesn't happen in the real world, at least not for money. At least I'm not aware of an investment like that. So we use PERT mostly for biological things. For example, how quickly is a disease spreading or something like that. Anyway, so here we go. We'll just plug in here. So A is going to be the principal. It's 23,000. Then E to the 0.049 times 6. And maybe I'll just calculate this one because you can't compound any faster than this. So I'll go on my calculator and I'll get E to the 0.049 times 6. That's giving me 1.34 something. I'll multiply that times 23. And I'm going to get 30861. And it's interesting to compare this one to the first one because this is going to be the lowest value because it's compounding the least frequently, just once a year, and then this is compounding every moment, every second, whatever the computer is programmed to do. And you can see, this sounds wonderful. Oh, it's continuously earning interest. Or this one sounds wonderful. Oh, it's earning interest every day. But you can see that really the difference is not that significant, even over a period of 6 years. So that's a good example of financial literacy right there. Okay, well, that's it for this question. I hope you spend time on this, and I hope you get comfortable with it because this is a formula that really is useful to you throughout your life. And hopefully you'll become comfortable with it. Okay, that's it for this one. I'll see you again next time. Bye-bye.